Okay, now as we said, if the flux changes from positive to negative, or from negative to positive, let's say, because that's actually what we're looking at, from negative magnetic field times the area to positive field times the area, and this again using the light as an indication of the magnetic field, negative, positive. The average voltage is the average rate at which the flux changes, the change of flux divided by the change of time, which is 2 times the magnetic field times the area times the change of time, since this is the 2BA is the change in flux. Now, if we rotate a loop, and let's again represent the loop by this CD, if we rotate the loop at a constant rate in a magnetic field, okay, not being real constant here, it's kind of jerky, but you get the idea. We see that the flux is constantly changing and the angle is constantly changing. If we look at the thing from the side to see the angle, okay, it's a little hard to do that with one hand, but the angle is going to change. And the angle changes at a constant rate, and we're familiar with the idea of angular motion at a constant rate. Omega is going to stand for the angular velocity in radians per second. T is going to stand for the clock time. And the angle is just going to be omega t. The number of radians per second times the number of seconds gives you the angle. The cosine of omega t is going to give us the orientation with respect to the magnetic field. Okay? Or is going to give us the omega t, the angle, gives us the orientation with respect to the magnetic field. The flux is just B times A times the cosine of that angle, as we defined earlier, and as you should hopefully understand from the demonstration there. Okay, so phi is BA cosine omega t. The voltage that we get is the rate at which phi changes. Now, here we have to invoke a little bit of calculus. Okay, now, theta is just omega t. The flux is BA cosine omega t. The voltage is the rate of change with respect to t of this flux. At any instant, we have to use calculus to find that, but it's very simple if you know a little bit of calculus and take the word of those who do. The voltage that we get is d phi dt, and the derivative of this is just negative omega BA sine of omega t. Now here's the graph of BA times the cosine of omega t starting at t equals 0. And here's the graph of a negative omega times BA sine of omega t. This graph is 90 degrees in phase ahead of this graph. That is, this graph goes through this low loop a quarter of a cycle before this one goes through its low loop, so that we have these phase relationships, which general college physics students will encounter to some extent, universities physics students to a large extent, physics 121 students won't have to worry too much about it. A couple of the details here. If phi equals omega t, then our theta equals omega t, phi is BA cosine omega t, so the average voltage is your delta phi over delta t. Okay, and your delta phi is a change between a time t and a time t plus delta t. So here's the voltage at time t, or the flux at time t. Here's the flux at time t plus delta t. Plugging in t plus delta t for t, that's our change in flux. We divide that by our delta t. The calculus of it is we take the limit of this as delta t goes to 0, and we get our d phi dt. Okay? And the d phi dt ends up equaling negative omega BA sine of omega t, just taking the derivative of this. The maximum voltage that we get is just what we get when the sine of omega t is negative 1. Sine is at between negative 1 and 1. Since this is negative, the maximum occurs when this equals negative 1, and that's just omega BA. And the average is just the maximum divided by the square root of 2. And that requires a little bit of calculus to show how we get the average, but it's fairly straightforward if you know the calculus. So that in rotating this loop through the magnetic field at rate omega, number of radians per second, in a magnetic field of magnitude B, a loop of total area A, the maximum voltage we get is omega BA. The average voltage is that maximum divided by the square root of 2.